Okay, so now let's go ahead and do this lesson, 14.3a. It's about the six trigonometric ratios. Now, unlike before, we've done the trigonometric ratios before, but unlike before, now the hypotenuse might be something other than 1. In chapter 13, we were always on the unit circle, and actually, sometimes we had ugly numbers like radicals, and things like that. These problems tend to be better numbers, okay? And so this point here, like here now, for instance, this hypotenuse here, r, might not be 1. It might be some other number. Okay, so that's kind of what we're doing now. This point here is point xy, but instead of being two numbers that would work with a unit circle, it might be like 0.34 or something like that, rather than point, what did we have before? Things like square root of 2 over 2, square root of 2 over 2, that kind of thing. So now this is just asking us, this first problem, just to write the different ratios down. So for instance, here, sine theta is the opposite over hypotenuse, so that's going to be y over r. Cosine is adjacent over hypotenuse, so that's x over r. Again, we're all doing it from this angle here, theta. And opposite over adjacent is going to be opposite, y over x. Now, we talked about last chapter that a reciprocal, you either do 1 over whatever that value is, or you can just flip the fraction. So in this case, cosecant is the reciprocal of sine. This is just r over y. Secant is r over x. I'm just flipping cosine. Cotangent is the reciprocal of tangent, so that's going to be x over y. And those are going to be our reciprocals in terms of x, y, and r. Okay, so now when we do a problem like this, here I have a triangle, and this is the angle. It says, what are the 6 trig values for angle A? So A is my angle, and that is important. Sometimes they might switch it up on you and talk about angle B instead. And actually, this one is number 5 is and 3 actually are doing that. And this is 4 here. I do have an F. My F on my keyboard is messed up. So if you ever see an or and it doesn't make sense, it's probably 4 is what that was supposed to be. Okay, so now going through this. Now I have these sides already established. It says that this is 13, the hypotenuse, and this is 5. It does not tell me the adjacent side. So you can either go through 5 squared plus b squared equals 13 squared and figure it out. Or you say, oh, Pythagorean triple, and you just know that's 12, and you're done, okay? So now we're going to go ahead, cosine of A, this is A here, is adjacent over hypotenuse, so 12 over 13. Sine is opposite over hypotenuse, so 5 over 13. Cotangent of B, now remember, cotangent is, we have it up here, x over y. What I usually do for them, the reciprocals, is I know sine, cosine, and tangent really well. So I usually just do whatever the reciprocal one is, and then I flip it. That's easier for me to do. But if you want to do it, just know already that instead of opposite over adjacent, it's adjacent over opposite. That's fine too, okay? So when I think of cotangent, I'm thinking, oh, what's tangent B? Tangent B, and now, again, we're talking about B here. So opposite over adjacent. For tangent B, opposite over adjacent, 12 over 5. So then cotangent's the reciprocal, 5 over 12, okay? Cosecant of A. So A is down here, my pen here. And cosecant is reciprocal of sine. Sine is 5 over 13. Opposite over hypotenuse, so this is going to be 13 over 5. Cosecant of B, okay, now we're talking about B. Opposite over hypotenuse is sine, which is 12 over 13, and this flip of 12 over 13 is 13 over 12. Secant is the reciprocal of cosine. Cosine is, and this is angle A, so adjacent over hypotenuse, 12 over 13, but I would do the reciprocal 12 or 13 over 12. Note that, some of these end up with the same values because depending on if you're working on angle A or angle B, you're going to get some of the ratios to be the same. That's why 5 and 6 are the same there. So, all right, so that's it for the first part, and we'll go on to the second part in the next video. Okay, so now we're going to go ahead and do problem. I had a typo in my original notes. Your notes are fine. It says for a standard position angle determined by the point 8, -6. So here you see the point down here, 8, -6. What are the 6 trigonometric functions or ratios? So sine. So basically, if you want to kind of analyze this triangle, yes, this angle is super big here, but focus on that the reference angle, which would be to the x-axis. And this is your little triangle you can kind of focus on, okay? However, you have to pay attention to whether x and y are positive or negative. The radius is always positive, okay? So the hypotenuse, the radius, always positive, okay? It's just the x and y values. So this one, I mean, x here is 8, y is -6. So you may want to write those down on your triangle so you don't mess it up when you're doing your angles. This is 8, this is -6. This is a Pythagorean triple. 8 squared plus 6 squared. It doesn't matter if you do -6 squared because -6 squared is also positive. And that would be 64 plus 36. It'd be 100. Square root is 10. So the side is 10. However, Pythagorean triple, this is a 3, 4, 5 with a multiple of 2. So that's why it's Pythagorean triple. So now let's go ahead. Sine is going to be opposite over hypotenuse, so -6 over 10. Now, if you can just do this in one step, great. If you can't, fine. But -6 over 10 is -3/5. So that's what that should be. Cosine is adjacent over hypotenuse, 8 over 10. Those are both positive numbers, and that reduces to 4/5. Tangent is opposite over adjacent. It's -6 over 8, which is -3/4. And then cosecant, cotangent are just the flips of all those. If you were just doing a random one, you'd have to maybe do a little more thinking. But here, all you got to do is just flip them like this. And -4/3. Okay, that's a -3/4 right there. Okay, so for the got it, I think it'd be nice if you could pause this, try to do this one on your own. But I will do it, but I feel like if you can do this one on your own, you're really in good shape. Okay, so when we do this problem, first of all, getting this point in the right spot, the point is -5, 12. And the other thing that students could make a mistake on is, okay, how do you draw this triangle? Do I draw like a horizontal line over to the y-axis or down to the x? Always make your angle to the x-axis, because as you go around the unit circle, the angle you're talking about, I mean, really, this is the angle we're talking about. But in terms of like practicality, it's this angle to the x-axis. In this case, it's the negative x-axis because we're in the second quadrant there. But that's kind of the angle that we're sort of referring to. So this is your point, -5, 12. And actually, you should know the hypotenuse because this is a Pythagorean triple. This is 13. Hypotenuse is always positive. Now I'm going to write my little ratios out here, so I'm going to pause it and do that, just kind of like the beginning, sine theta, cosine theta, that sort of thing. Okay, so I'm just going to go about my business now and write down these ratios. The first one, sine, from this angle here, is going to be opposite over hypotenuse, 12 over 13. Cosine is adjacent over hypotenuse, -5/13. Tangent, opposite over adjacent. So write the negative in front, 12 over 5, -12 over 5. And then the reciprocal functions are just these flips. So this is 13 over 12. 13 or -13 over 5, let's say, put the negative in front, and -5 over 12. Why is this the 5, 12, 13 triangle nicer than the 6, 8, 10 that we had above? Is because I didn't have to do any reducing of the fractions here. It was just all kind of taken care of for me. All right, so that's that.